Thank you, Eva, for organizing such an incredible event. So many days of talks and interventions and actions and art about this topic. And, I was going to say this talk's going to be a little different than some of the other ones, but I guess they've all been so different in form and structure. Traditionally, it's believed, according to Groucho Marx at least, you should never go on after an animal. But now I think you should never go on after a vacuum cleaner. Like, what can be done? If you're going to go on after a vacuum cleaner, at least it should be about animals. And I spend a lot of time making music with animals, and, I'm going to address the question, is there aesthetic thinking involved in the music of animals? I can tell you right away, I believe the answer is yes. And I'm going to show you by demonstrating the history of these experiences of mine. And I'm going to show you first, this is the first moment I was actually playing live with a bird. I decided it might actually be an interesting thing to do. Yeah, so this is maybe 17 years ago, I think, 2000, at the National Aviary in Pittsburgh, a place you should visit when you drive to New York from Chicago. And this is a white-crested laughing thrush, a very common bird in India and Southeast Asia, and one of the best birds to try and make music with, I discovered at this moment, because what he does is interact with sound. He's not competing with sound, he's not just singing alone with sound, he sings duets with sounds, usually with female laughing thrushes, of which there were none to be found on this day. So he was surprised to hear something close enough to the kind of sound he was interested in. But I wasn't thinking about that at the time. I only read about that stuff later. I thought, musically, this seemed like an interesting encounter between me and this bird, and I didn't know what it meant, but I thought maybe it was worth investigating. Is the things that birds doing really have anything to do with music? And, I started listening to a lot of bird songs, like the song of the veery. I believe this bird is named after the sound. It's a veerying kind of sound. It's a very common sound to hear in spring in eastern United States. Most people don't know what it is. It's just some weird sound. You never see them because they're kind of brown and hidden. But what's really strange is what happens if you slow it down and lower the pitch. It turns into this. What? How can this be? It turns into this, which sounds so musical, at least to me. Why do I think it's musical? It's a phrase that has a beginning, middle, and end, a shape and a form. It has an inflection, like it's sung with a sense of swing even. It's like a jazz solo. It's like a trumpet solo. Is this how the birds actually hear them themselves? You know, it's believed that birds can hear 5 times faster than we can. Scientists who've tested this out. And we know that this sound to the Viri means a lot more, that one sound to this bird, than it could ever mean to us. It's not invented for us. There's a lot of birds that look just like this. Hermit thrush and Viris look almost identical. Maybe if you're an ornithologist, you would dispute that, but the songs are also related but different. A hermit thrush, the Viri is almost unnoticed by commentators on birdsong. Nobody writes about it, except there was one Indian guide in the 1870s that said, that sound really makes me sick. Otherwise, I found nothing written about it in the traditional text, but the hermit thrush has been praised by everybody. Thoreau, Henry David Thoreau, loved this song. John Burroughs, a naturalist, loved this song. Even T.S. Eliot, sitting in London writing his poem in the 4 quartets, he has the hermit thrush sound, which he must have remembered from being in Boston. If you slow it down a little bit, it becomes like this. The thing is that all these people said, this is an incredible example of bird music, and yet it's so far away from human music. You can't say what key it's in, you can't say, you can't define the notes in a scale so easily. People have tried, and they're not quite correct when they do that. And yet, for hundreds of years, people have heard this and said, this is music. This is a musical thing. Now, if poets and naturalists, first of all, poets, I'd say, started to take these bird songs seriously in the 1600s, 1700s, 1800s. There's a lot of poetry based on the sounds of birds. And there's some music inspired by the songs of birds, but not as much. And there's absolutely no science about the songs of birds until they figured out how to turn the sounds into pictures. And all of us discussing the image here and what is the visual and the oral all about. When we figured out in the 1940s how to instantly visualize sound, make these sonograms, only then did biologists say, let's study these artifacts, this data of birdsong, as something we can sit and study. We don't have to transcribe it because it kind of doesn't work well in musical notation usually. But we have a picture of the frequency against time. So you have like an instant graphic score that gets, instantly made by your machines here, and then I've slowed it down even more here, and when I slow it down this much, it becomes like this musical world that as a musician, with this recording of the slowed down hermit thrush, I really want to interact with it. So we'll see what happens when I do. So here, it's changing the scale of this phenomenon, from something fast and high into something slower and lower and stretched out, so there's space for a human musician to interact with this song by playing along with it and doing it so many times as I have over these years. I really feel that I'm learning some valuable musical stuff here that I can use. People always ask me, what did you just play? Is this, what are you doing? Is it improvising or composing? I've done it so many times that I would say, I know how the Bird song, this version goes, but yet in playing it, I always try to make sure it's not the same as I played it before. And one thing that's come up a lot here is what is more valuable or serious? What kind of music? Improvisation or composition? We've heard the view here that composition, you can make giant, huge structures and spend years writing them and create these huge experiences. It's all kind of designed and planned out by the composer. You think you can do anything like that spontaneously? You think that's, and of course in one sense you can't, but in another sense, those who believe in improvisation, either musicians or listeners, they all feel as, Jason Moran felt. There's an article about him in the New Yorker a few years ago where he was quoted as saying, we improvisers, we're doing it because we're making a kind of music we can make no other way. You could write it all down, do the same thing, it's not the same. It's a different kind of musical experience. I know for me as a listener and philosopher, I've always wondered, how I could articulate why I'm more interested in improvisation, even though I'm sympathetic to those arguments that maybe it's just not as serious. But why do I like it more? I think it's because I feel I'm about to hear something that's never happened before, and that it's made by those that believe you can create something spontaneously and together with others, that it's best not a solitary activity. And you can create it with other people, but what really fascinates me is you can create it with other species. You can communicate with other creatures, and we don't know what they're talking about. If you think animal sound is language, it's somewhat inaccessible because we can't really translate it. But if it's music, we have no idea what human music means. We know it's important, but for all the discussion, for all the years of wondering about this, this profound uncertainty, thousands of years of humans wondering what music means, we cannot really say what this assembly of sounds really means. We know that we need it and it's important. And if you think animals are making music, then maybe we can communicate with these beings without knowing exactly what they're talking about, because they're making music. Now, we'll come back to nightingales after going through some other creatures, but over the years of doing this, I got interested even in playing with creatures who are not so clearly individuals and making these songs with a structure, but like playing with bugs, This has all kinds of other challenges. Of course, there's just as many 17-year cicadas inside my clothes as out. That's what makes it more difficult. These, of course, are the famous 17-year cicadas that come out only once every 17 years in the millions. So this is in Lake Springfield, Illinois, 2011. If I go to this spot, I'm going to have to go back, 2028, so, to find them like this again. It's a good thing I was there on this day. So you might say, well, that's clearly crazy. This guy clearly is crazy if he's just playing with all that noise. But what's so interesting, as you're going to learn, is this wash of sound that seems like noise. Literally millions of cicadas in one spot. 17 years of silence, then they're back. This may, in fact, be the longest rhythm in the animal world, a beat of 17 years. Then they're back. But people, you might think it's noise, although not you, you're a sophisticated group. But for a long time, people really have appreciated insect music. Here's a painting by the American artist Charles Birchfield called The Insect Chorus, where he's sort of painting the sounds of more common singing crickets and other species of cicada outside his house in Buffalo, New York in the 1930s. Like this is the sound is an organized, beautiful, swirling thing. And then, of course, fireflies with their lights and rhythms, pulsating. I don't think you have them around here, but they synchronize visually, blinking, communicating with each other. And this is similar to the way that crickets synchronize. This insect, by the way, is this big. They're very common. You don't usually see them because they're in the tops of trees. The snowy tree cricket sounds like this. And they sing at different speeds depending on the temperature. So sometimes they sound just like this. But what's quite interesting, the crickets is not as complicated an organism as a bird, but it's still pretty complicated. There's hundreds of scientists trying to figure out the structure of crickets' brains, and they're making progress, but they still don't really know how it works. And one thing they do know is how they manage to synchronize sound. And what this is, if you hear a lot of crickets going, different kind of rhythms of them, they come in and out of synchronization. You hear this, it's quite common to hear. And you wonder how much they need to know to do this. All they need to know is they follow a mathematical model, a phase delay mechanism. When they hear a sound, they try and move closer to it. And sometimes they mess up, then they move further away. And that's how you get the approaching of a synchronized rhythm. And certain neurons have been identified in the cricket brain that make this work. However, I didn't really believe it worked, so I had a friend of mine write this computer program. Let's just try it out. Let's have a bunch of cricket sounds and see if they would synchronize following this mathematical model. So there's a lot of numbers here, and this is just and we made them different pitches to make them kind of more interesting. And they come in and out of synchronization. So let's see how it sounds. I haven't listened to this one in a while, so. They listen to the closest sound that's around them, and they gradually get closer and closer. And we just made them different pitches to make it easier to hear this process. And after a while, they'll all be together, and you just tweak one number and make it out, and then they all go apart. They don't need to know too much to make this synchronized, cricket-inspired music. And you want to try that out? You can download that from the Ableton website. Try it yourself and put in whatever sounds you want. And I heard people have used it to synchronize lights at concerts, things like that. And in fact, the whole process, this kind of synchronization, is used in the internet at super high speeds to synchronize phenomenon, and it's called firefly synchronization. So this little bit of mathematics that enables insects to make this beautiful collective music has a lot of applications. The other thing that's interesting about insect sounds is they all find their own place in the acoustic sphere. This is a fairly famous sonogram from Central African Republic. Different species of cricket and cicadas, katydids, frogs, and people are singing. Women are singing. These are the Bayaka pygmies. And it's given an example of this is a society that really fits in sonically with its environment. So if you've never seen these pictures, it's a higher frequency, and this is time going across. And we looked at single bird sonogram before, and here is kind of ecological acoustic vision. Humans and insect music all together. And in the world of the Bayaka pygmies, people are singing all the time. They're just making music all the time. The world is full of music. This is what led the American kind of traveler, Louis Sarno, to move to Central African Republic and live there for 35 years just recording their music. And this is the subject of a very well-known documentary film in Germany called Song from the Forest, which I was happy to work on and produce the soundtrack and make them put more music in it throughout. And, what was so interesting is this is a society where singing along with animals is just part of life. It's just right there with all kinds of overlapping creatures, the whole ecological situation. Here's a little bit of the film we're not going to see right now, but we're going to continue this insect sonogram direction to show that it's very important to turn the sound into an image to make sense of something that's a complex noise and see it as the beautiful thing that it is, and also the beautiful and comprehensible thing. What do you think this sounds like? Who wants to sing it? Ready? Ah, it's pretty good, yeah. What do you think it is? It is one cicada. Cicadas don't really sing, they're vibrating something on their abdomen. And look how precise it is, just as a thing, as a gesture, as an action, as an event. So look at this thing. And now let's listen. Sorry if you don't like it. It's very hard for us to describe this sound, talk about it, and discuss the frequencies, make sense of it. But the image, I think, shows so much, the mixture of noise by the complexity and the harmonic quality going across like this, and getting more noisy, and like it's just craziness. And how does it just stop like that? How can they even do this? Yeah, it's a good thing these 17-year cicadas are not that loud, because that's just one. And here we have millions of them. You get close up, they sound like this. You heard them before with the saxophone. Now we're a little closer to them. You see, it's a little more clear, not just white noise or any other color noise or black, red-eyed, black, brown-winged noise, but a kind of mixture of sounds. In fact, what you have here is 3 different species that come out every 17 years. Each one is making up to 4 different sounds. It's like an orchestra of very specific activity. There he is. When these things were named in the 1800s, they were called Magicicada septendecim, like scientists classifying naturalists. They knew these were like almost magic, these crazy things coming out every 17 years. This is where to find them, which year, where you want to go. It only happens, unfortunately, in the United States. Often the kind of right-wing leading Trump-type states are very populated by cicadas, but we're hoping by 17 years from now that's all going to change. The next generation of cicadas are going to think differently. And, so 2011 we were back, we were in this area, this group. And so the life cycle of the cicada, people ask how long do they live? The answer is 17 years. They're alive underground that long. It's the longest living insect. They're waiting to come out. They're preparing. When they come out, they're not eating much. They kind of sing, fly, mate, and die. And this is a kind of David Attenborough type picture. How many cicadas do you see? There's actually 2. One is the male, one is the female. What does the male do? It makes this one sound. It's called the pharaoh sound. Pharaoh. Is this music? Is it language? If you hear millions of them, the shape disappears. It just turns into a drone. I consider this a musical strategy, how they all blur together. So I'm artificially just duplicating it so many times that it becomes like... Okay. It used to believe, a lot of the theory of what animals are up to is based on the idea that males make the sounds and the females are somehow impressed by this, like peacock's tails, and then they sort of decide which males they like. And in those certain species where there's excessive behavior, like long songs, nightingales and mockingbirds and crazy cicada activities, this is where evolution has gone a little crazy. That very extreme behavior. It's rare. Usually it's much quieter. But in this case, that's what was always thought, except that's what people think, but nobody bothered to go out and listen and study what was going on. And there were 2 scientists about 20 years ago. They decided that the cicada stuff is so complicated that they can't really find the right species unless they're doing more. There must be some other sonic activity. And they discovered the females are also making sound, and they have this whole ritual. And although the ritual fits on one page, this is the most complicated sonic interaction of any insect species. So now I'll explain it to you in case you want to attract cicadas, whether you're a male or female cicada. This is what you need to do when they come out. So first the male makes a call. And then the female makes this tiny wing flick, like this. She's just going like this. This is very amplified. And then he goes again, does this. And then she does this again. And then he switches to this one. And all the other sound is going on. And then when he's done, then she goes again. And then while they're actually mating, makes this sound. Right. So you can hear all this stuff, but what's so fascinating is nobody noticed it until these two scientists decided we're just going to really go out and really pay attention to these characters. And unlike a lot of other animals, there's so many cicadas, you can really watch them. But actually paying attention to what's happening in nature and really listening can change what you find out, even in the modern world. Just perception, just listening, you can learn a lot. There they are. You know, and cicadas, of course, are very easy to photograph because there's millions of them around and they're kind of friendly. They like human music. They like electronic sounds. They'll just fly onto iPads if you play along with them. It's possible the iPad was invented primarily to play music with cicadas, so, yeah. And I have to say that as a musician, you know, working on this whole bug music project got me more and more interested in these kinds of sounds that previously I didn't take so seriously, being more interested in melodies and structures and birds. And you could play live quite successfully with cicadas because they behave well. You take them in a concert and put them on the microphone, they start to sing. And, you know, although I don't have these cicadas anymore, you know, we're able to get them to behave. They can sort of settle down first, and on the microphone they start to sing, and then we can capture their sounds for later use. And then none of them were harmed. You can bring them back the next day to that tree you saw before. So when I'm trying to make human music out of this, I feel like I'm making music that could not be made by one species alone. Like it's through the encounter with all these stories I'm telling you and these discoveries that makes me interested in different kinds of sounds in a new way. And the notion of this, the pharaoh sound, becomes like this iconic idea. And just keep thinking about it once you hear that story. This was the motto of this whole project. We had t-shirts, hundreds of them made, that said this: sing, fly, mate, and die. The same fact about cicadas was noticed by Plato. He wrote about their activities. So even though those weren't 17-year cicadas, they knew something about the music of these. That they thought that these sounds were musical. Why? Why is this musical and not linguistic? I think it has to do with the performance of these structures and shapes over and over and over again, and this being sort of necessary for the lives of the animals, the lives of humans. So we'll get more about this. In Asia, in China and Japan, I don't know about Korea, probably also, there's literally thousands of poems about singing insects. Like Basho, cicadas sing, know not how soon they all will die. They just have a few weeks out. And this is my favorite one: some hear bug music, some hear people music. All depends on your ears. And so I wrote a book about, each of these topics became a book, and these books combine science and the history of literary responses to these musics. There's one on bugs, there's one on birds, why birds sing. That's the only one also available in German and Korean. And then there's one on whales. We're going to talk about whales next. And then after that, we go on to nightingales, which is the next book and recording project I'm doing. But, okay, so insects, you know, they're making, you know, we went quickly through this, but they make music a different way. Each one doesn't need to know so much, but together they produce these whole environments of sound. Now, to play music with a whale requires a certain technology, and this is how to do it in case you want to try. And you're going to be on a boat playing an instrument. You need an underwater speaker and an underwater microphone. Humpback whales are this one species famous for these long, complicated songs. So here's a fragment of a live performance with clarinet and whale. if you're a connoisseur of clarinet and whale duets, you will notice at that point the whale is trying to sing a continuous pitch, which they never do. So this is like a fragment of evidence that maybe he's actually interested in what the clarinet is doing. Often you cannot tell. But that moment, since they're always going, the idea of a held-out note is a surprise. Okay, people don't believe I really did that, so I have to show you this film. It's from a French TV documentary, How to Make Music with Whales.
We're going out to meet the whales and make some music with them. Come on.
Sound travels very far underwater. You can hear whales that would be 5 or 10 kilometers away, and they sound like they're right there. They tend to be like 1 kilometer or so apart from each other. And, you know, each one is singing this song, which you'll soon learn about. They're kind of doing it on their own, but sort of overlapping. All right, so this phenomenon, we've heard about bird songs and insect songs, and obviously, as long as there have been humans around, we've heard those sounds. But the fascinating thing about the song of the humpback whale is nobody knew about it until the 1950s, when the American Navy and the Russian Navy started listening underwater and doing underwater war activities. Listening, and they started hearing these sounds that sounded like secret codes, and they were sure the Russians were behind this. I've seen the book saying, like, scientists claim these sounds come from whales, but we're not so sure. This man here, Roger Payne, was one of the pioneers who realized this phenomenon was extraordinary and delved to kind of investigate it. Here's a little fragment of whale song with sonogram. Here underwater, there's a lot of harmonies. It adds this ringing quality. The parallel sounds means it's a rich tone with a lot of overtones. It still has a pitch. You play this for little kids, they think it sounds like farting or mooing cows. I said, yes, but look how structured it is. Start to pay attention to how it all fits together. There you have a thing that cows do not usually do. And yet, it's still kind of hard for people to grasp what's actually happening. And when the sonograms were, in the 1960s, to make a sonogram took a lot of work. You could print out like 10 seconds, it would take like an hour. And then another 10 seconds, and then more and more, and these very hard-to-find machines. And then they cut and paste all the printouts together, Payne and McVeigh, and Scott McVeigh's living room in Princeton, New Jersey. And then they saw, look, there's a whole structure to this activity. And they got this image on the cover of the journal Science, because it was seen as so important that humpback whales were kind of making something structured, like a piece of music. Even more interesting was in the paper, 1971, they wrote this very interesting phrase. The humpback whales emit a series of surprisingly beautiful sounds. Now what's interesting is this idea of beautiful sounds comes up in a science paper where you're not, as a scientist, supposed to talk about stuff like that, unless you're going to define exactly what a beautiful sound is. In the hundreds of papers written about humpback whale songs since, no scientist has dared mention the word beautiful or beautiful sound unless they quote this phrase coming from these guys. But they didn't care because they just heard how beautiful this was. This is like a score of, each line is about a minute of the structured part of a humpback whale song, and it has different sections. You're all experts on sonograms, so you can sing along. Go ahead to or down here. And so this is not a transposed whale song, but all part of what these giant bus-sized animals can do. Unfortunately, we have no idea how they do it. No one has any idea how these whales make this sound. No air leaves the whale. It's very hard to ask them or cut them open and watch it happening. Whales with teeth, like dolphins and killer whales, they make sound a whole different way. So we know that's different. But then, Payne and McVeigh pointed out this is structured, this phrase is structured like a sentence or like a piece of music. There's units, phrases, themes, songs, and sessions of songs. They identified that. And then they've started to find some really weird things. Like year after year, the songs evolved. And all the whales were singing the same song in any one ocean. But, why would they all want to sound the same, then why do they want to change it if they all want to sound the same? When birds' song varies, it's one individual from another. The individual is trying to distinguish himself by being different than the others. The whales all want to sing together, but they evolve the song together. Okay, they figured out only the males are doing this. It even happens from month to month, this evolution. Only the males are singing. Of course, it must be to attract the attention of female whales. So 50 years of studying this, how often do you think people have seen a female whale show any interest in these long, beautiful songs? What do you think? Never. They've never seen any reaction. Of course, one view is they don't want you to see that. It's not something you see. It happens. So we don't know. We've seen nothing. And the one study that actually watched what happened made the following conclusion. 80% of the time, two whales are singing 1 or 2 kilometers apart. They stop singing. They swim together. They go in silence, parallel, the males, and then they separate and start to sing again. So that ritual has been observed by this one paper. None of the other scientists like it. They say you guys are making that up. It's too strange a behavior to have seen. And yet we saw with this strange cicada behavior, people thought, no way do the females make any sound. And so, you have to go out and observe. It's very hard to observe whales. But very important, at the same time these scientists said, we're publishing a paper about this, the world has got to hear these sounds. It took 15 years before the Navy declassified secret whale recordings. And then Payne and McVeigh said, we're now going to release this album, Songs of the Humpback Whale. This is the cover. It's kind of like the White Album, except with a whale on it. But no information, It was also notable that it contained a 48-page book in English and Japanese saying, we really shouldn't be killing all these whales and hunting them to extinction because they make such beautiful music. Well, that's not in from there. And that might be something you've heard, might be a well-known idea to you, but it was not at the time. In fact, the environmental movement had nothing to say about whales until this album, which is the best-selling nature sound recording of all time, a multi-platinum album. It was the basis of a Star Trek movie directed by Leonard Nimoy, Star Trek 4, They Come from the Future to Save the Whales. And because the whales are needed in the future to communicate with an alien race. But it was this song that made the world interested in saving whales. And that's an extraordinary story in itself. You also at the time had this world of this kind of mixtures of science and kind of new agey activities. This famous book, Mind in the Waters, from Sierra Club books, poems, stories, and paintings like this of humans and whales living in harmony. It's a totally trippy book. But some of the papers are by scientists. And they're just writing poems about whales. And the same people, you look years later, they deny having written these texts. They never refer to them in their bibliographies. And there was a different sense of being, which kind of continues today. You can go to Hawaii and go out on boats and sing with whales, play music with them. But it's against the law. So you're not going to find these trips listed anywhere. Although I can hook you up if you want to go. You can take your clothes off, take out your didgeridoos, and stick them in the water. And The whales can hear you. There's a lot of whales. They swim around. Maybe they're laughing at us. This one's smiling a bit. And then, this is totally against the law. Swimming with whales, don't do it. It's forbidden by the Marine Mammal Protection Act, put into law by Richard Nixon. You have to protect marine mammals. That's what Republicans used to talk about in the 70s, protecting nature. And however, it's not illegal to wait for the whale to come to you. So get in the water and hope he comes in your direction. Cello is good for playing with whales. Roger Payne himself would play cello to whale songs when he would give talks and travel around. Okay, so I was very interested in this visualization, the structure of the song and the humpback whale, and the fact when I would show these pictures, people had no idea what I'm talking about. Nobody can understand these sonograms, and people still think the whales are just grunting and make one sound, go, roo. That's it. That's what people think whales sound like in all the Disney movies and The Simpsons. There's always one sound of the whale. People forget it's this whole structured music-like thing with sections. So I tried to find a contemporary graphic designer who might be interested in changing the way sonograms appear. And I worked with this guy, Michael Deal, who works for Vice now. He used to work for Google. He designed the Pinterest logo. I said, can you improve sonograms? Don't read anything about this. Just listen and make better ones. So he said, okay, let's see this cover from Science. Let's make our own colored glyphs that kind of represent this kind of sonic poof, this thing. Oh, it's sort of like music. Let's put it on a musical staff, to show people these overlap with sounds. And voila, a whale song score. This one's from Tortola, 1992. We're already here. So here again in one picture with some added color, we have a vision of the structure of the song. Then maybe here up here. Maybe you can help people grasp the thing. And this is our version of the hierarchical structure, how this is put together. Here's in Maui, and each ocean has its own kind of song, and this is a few decades later. So you hear a Maui whale sounds like this. It's a little more chill. Right? But we still recognize it as a humpback whale song. It has many of the same aesthetic qualities. And then I made this animated version, which I'll play along with a little bit for you. I think to get people to understand this, it's helpful to do a concert where you just play this for an hour. This is it. And then you find a way to try and join in. I'm just doing a few minutes. But with enough time, you start to feel like this whale stuff is like music. Because it's structured, it repeats, it has this shape and form.
something about these sonograms when they were invented in the 40s and 50s. Scientists who were visualizing sound said, great, we could help people who cannot hear, we could help the deaf learn to speak by looking at sound. And every time I told that story, I said that it was generally considered kind of a failure, like it didn't work as well as they thought. But I showed this movie and said that thing at a talk a few years ago, and a woman came up, who's Maria Batia. She said, I work teaching music to the deaf in the Dominican Republic, and they would get it right away. My kids would be singing along with whale songs, looking at these pictures, and we have humpback whales there. So why don't you come down and try this out? And it worked great. We got these two kids who can't hear anything. They're feeling the whale songs and singing along with them. So the speaker is the sound from the whales are underwater, and other guy's wearing a sub pack. He can feel the bass. So these sonograms really can work to make sound be explained to those who can't hear anything. Okay. We had thrushes, cicadas, crickets, and now on to nightingales, a project I've been working on the last few years. And here we're going to show a little more science. You hear how scientists really are trying to make sense of the structure of sounds. And these scientists, in many ways, they're as skeptical as many of you philosophers out there, who I'm sure are thinking like, he's talking about music. Why is he talking about music? He hasn't defined what music is. It's just like structures and sound. We must analyze it without our preconceptions. So we'll see how that works out. So nightingales are so interesting because they really sing and sing and sing, and this bird knows, two species of nightingale, the one you're going to find around here in Germany, they know about 150 to 200 different phrases, and they sing them one after another, and they're a textbook example of, a bird that is using sound for very specific purposes. This is one in Hasenheide in Berlin this year, and, nightingales sing in spring for like a month and a half or so, depending where you are. April or May, it's going to start. The males are singing. They come back to the same tree every year for like 7 or 8 years. They live 8 to 10 years or so. So this is the Treptower Park, 2014. Each of these birds, if I go there this next year, I'm going to find mostly the same birds. And I know they have certain qualities. These are color-coded by this team of scientists. So I know that this bird I particularly like. Who is right? Yes. This guy, number 6. He knows a lot of songs. I think that's why he's got these colors here. And, the last few years he's back. He comes back, and this bird just knows more different songs than the other ones. Does that make him more successful at mating and defending his territories? They're trying to collect evidence demonstrating that's the case. So here's a little bit of a nightingale sonogram. What I found so interesting as an American is when I first heard this bird, which I think was in Helsinki like 20 years ago, I couldn't believe that was a nightingale, this bird that sounded like kind of electronic music. I thought they sang long, mellifluous melodies because I had been reading Shakespeare and John Keats and things like this. But they sound like DJs, synthesizers and scratching records. This is crazy. This sound is very important here. It didn't come through that loudly. Let's see if it comes back again. A paper by these scientists demonstrates that's the sexiest sound. That's the one the females really like. And just like a sort of human musician, the nightingales don't use that sound too often because they don't wear out the effect. There's again, It's like a kind of wah-wah pedal kind of cool sound. Okay, so they have 150 phrases like this. Can we really understand them? Can we study them and learn enough what the best Nightingale song would be? The best Nightingale song, what would that even mean? Well, it turns out this whole idea, it plays very heavily in Darwin, in The Descent of Man. He has 2 whole chapters on birds, because he saw in birds this kind of evolutionary change that was not the same as natural selection, which is survival of the fittest, behaviors and traits that enabled a species to be more fit. These birds, peacocks, had this huge tail that, was insane. It had no point. Think how much work it is to drag around this whole thing and this great, beautiful fanning thing. This is clearly another phenomenon at work. Sexual selection, where certain animals evolved certain traits. One sex evolved a trait, the other simply because the other sex preferred it. Often it's the females doing the preferring, but not always. And so this is an explanation for why there is complex bird song. What the nightingales are doing with the song, attracting mates and defending territories, is done, say, by the chaffinch just with the song, that's enough for that species. Why does the nightingale have to have 200 syllables and go on through the night? Simply because that's how it evolved. It was excessive sexual selection, runaway sexual selection. So, this team of scientists based between Germany and in New York, Ofer Chernikovsky with a laboratory at the City University of New York, now at Hunter College. Christina Roske was working there. She's now at the Max Planck Institute of Empirical Aesthetics, which is just a great idea. There is such a place. They mostly don't study stuff like this, but other things. But how would you, as a scientist, make sense of the complexity of birdsong without thinking about music structures in this? So this is what she figured out. Let's study. Let's try and analyze them in a mass way. So let's sample all the songs here, line them up. This is like scientific diagrams. Let's organize the songs rhythmically, because rhythm is easier to categorize than pitch and the other stuff. We line them up. We color code only if it's really loud, then it gets to be like this reddish color, and then blue is like closer to silence. So then we compress them and then line them up, and you can have this picture with thousands of songs in one picture. So this is kind of big data analysis of birdsong. That's it. All the 6,500 songs, they had, maybe how many, 20, 30 birds, and all the songs they made together. Let's categorize them, try and make sense. How do the birds use the songs? And so this is how they sung them, in what order, and this is clustered by similarity. It all looks like a big mess, right? But, the way they moved from one song to the next varied from bird to bird. So different birds have different ways of being more random or more patterned in how they go. And so what about the order? Certain birds seem to have what she said was a random order, and then other ones, in other birds, in most birds it seemed like they couldn't find a pattern for the order in that study. Another study by other scientists point this diagram, which is extremely important to my Nightingales in Berlin project, the orderly bird versus the disorderly bird. And according to the scientists, the orderly one is like a composer. He has his sequence. Every time he performs, it's the same order. But the disorderly bird will surprise us and go this and do this song and this phrase and be kind of very random and surprising. Okay, and so we published this paper about this. I wouldn't say that I'm a scientist, but I was happy to be the author of the science paper, which is based on a question I raised in my book saying, why don't you scientists study complicated songs instead of simple ones? And they said, yeah. Okay, we'll do it. It took like 5 years of analysis. And what the paper basically says is there is a way to quantify and investigate birdsong. However, Tina felt that her research was inconclusive. So the birds are random. We couldn't figure out. I couldn't figure out what, anything worth saying. And she said, I spent 5 years on this. I think I was transfixed by the beauty of the song. She said, as a scientist, I got too wrapped up in the beautiful. Messed me up. But this year, she finally found out something that she could prove in this song. And this paper came out a few months ago, and this was widely quoted in the popular press, that birds have swing. Multifractal analysis reveals expressive rhythm in birdsong. This is how scientific discussion of the same phenomenon. Basically, what she's talking about here is how, when humans are playing, a lot of fast
repeating things like in the Earl King, you know, Schubert. You know, it's all fast and rhythmic, but if you made it all the same, like a machine, it's not the way you're supposed to do it. Anyway, she said the birds do the same thing. When a nightingale is playing, it's not all exact. It's not like a machine. It has this uneven evenness that's maybe similar to the articulate inarticulateness we heard about before. That seems whenever we're talking about aesthetics, we go to something that's organized but not organized, that can be decided but not decided. This uneven evenness, that's what makes the world interesting, makes life organized and surprising at once. So that's what they concluded. Some examples of trying to show what it is. Anyway, but as a musician, I just wanted to go out and play with these birds and get people to hear it, do these concerts in the dark. In the Treptower Park and Hasenheide Park in Berlin. We tried resampling the birds live and playing along with them. Yeah. I think this one has more sampling. So you can play the nightingale, you can slow it down, speed it up live and do it. And this is a bird that interacts live in real time, unlike those thrushes I was talking about. And they're going to keep going. That's the sped up one. And you know, the one scientific paper written by scientists at the lab in the Free University, where they study this stuff, said, look, there's 3 different ways a nightingale is going to respond to another nightingale. When they're establishing their territories, they interrupt each other. It's like a battle. They're trying to jam the signal of the other bird, get in the way. Like in Peter's piece, you have one voice jamming with another one, getting in the way. You can't hear after a while who's saying what. So the birds are trying to jam the communication. Once they decide this is my territory and this is yours, this one sings and waits, then this one, back and forth. They kind of acknowledge each other. And then a third kind of bird who thinks he's really important pays no attention to anyone else. And just, maybe I sing, maybe I don't. There's nobody here. My song is so brilliant. And you know, if you've ever tried to play with like musicians you don't know, you'll run across these 3 types among humans easily. Now, of course, the musicians, when they hear the overlapping, they don't always see it as competition. They might see it as musical interaction, which is kind of how I prefer to see it. I worked a lot with a Turkish musician, Korhan Erel, and we made this album. And he's sort of sampling the birds, playing electronics. I'm playing clarinet. We did all these concerts. And then we're making a film about this now. And so we're bringing in all different musicians. Here's a singer from France, Lembeloc. This is the first time she got to sing along with the nightingale. You'll hear the fast, swinging kind of sound, and you see if you think it's perfectly even or not.
Dreaming slow. My mind is sitting there. My voice is breathing traces of her. It's the first time I sang with birds and with nightingales in particular. At the end, when you get really into it, you feel like flying, actually.
So for me, like using music to communicate with these other species in these encounters that are hard to explain and analyze, you know, it's a little different than the way the scientists are trying to use this phenomenon, collect the data, analyze it, categorize it. You know, I really feel that the musical encounter is a form of knowledge. You know something by playing along with this phenomenon, and by kind of working with it, by living with it, by spending time with it. And if you look at evolution, you know, these phenomena of some of these extreme animal sound activities, thrush nightingales, humpback whales, these are extreme examples. There's no other whale
species that does anything like this. There's a comparatively few birds that sing these long, complicated songs, and there's something strangely parallel about these animals and what they're doing. If you go back to where we started, speeding up and slowing down sounds, here's a humpback whale. Now you're used to seeing these pictures, you understand the structure that's happening. Here's the fast part of the whale song. Now let's take the same thing and speed it up. The sped up whale song. That's kind of the same structural balance of slow parts and fast parts as you might find in a nightingale song. And now the nightingale song. And now you take that same thing and slow it down. Same kind of shapes, but they're bigger and lower. It's going like... Why? Why is this phenomenon like each other? We have no idea, except it's a form of convergent evolution. These unrelated animals evolved something similar, this kind of excessive music, this kind of need to musically express and repeat and sing much more than you think they need to. They're expending all this energy. Why do they need to do this? Other whales don't need to do it. Other birds don't go on this long. Evolution does not. It's not just survival of efficient, fit activities. It's like survival of the beautiful. Crazy stuff evolves. It gets through the process. Millions of years of incredible music have evolved out there. Our music is just part of that, one choice among many. And I think all sense of human music evolved in a context that sound like this was out there millions of years before we appeared on this planet. Sometimes explicitly, sometimes implicitly, we've known about this and learned and built our whole musical culture out of this whole evolutionary history. So I'm surprised that animal music isn't required study in all musical education systems around the world. We should all begin with this, just like how in art classes you have anatomy and you're often like drawing and painting animals and still lives, and we should all know something about this musicality of the animal world and how this connects to everything about us. So thank you. I'll stop there, answer some questions. Mm-hmm. 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 Thank you. Thanks a lot.
There's the first question.
Thanks very much for this brilliant talk. The first remark about cicadas. The Japanese composer Toshio Hosokawa, he's about 55 years old, he said he was inspired to become a composer by the songs of cicadas in the surroundings of Hiroshima, his hometown. So that's a nice example of a connection between animal sounds and the compositions of a very famous composer. Now, you were quite often saying, some people might think these are just random sounds what animals produce, but that's not your position. You say, no, there's structure to it, there's something like composition to it, so it's music. Now my question is, this reminded me of a work of someone I recently came across, Bernie Krause, who writes about the great orchestra of animals. So it seems to me that he goes even further because he says they even make symphonies. Would you go so far?
I mean, yeah, the one example I showed from Africa is a Bernie Krause example of this environment. And what they make is acoustic composed environments. And, do they make symphonies in the sense of having that kind of structure? In some senses, yes. You can look at the overall structure of one acoustic place. You can look at one day in a landscape. You can look at 1 week. You can look at 1 year in one image, similar to those nightingale sonograms I've seen, for an entire year in one picture, showing how the sound changes in each day, one line, and you see various levels of structure, and you hear overlapping beauty and things like that. Now, I probably wouldn't use the phrase symphony, because to me that's very specific kinds of structures. But I basically would agree with much of what Bernie Krause says. Like, you know, he's a pioneer of recording environments. He's really worked for maybe longer than anyone on this and produced these beautiful installations and recordings of whole environments. But I'd also call Bernie Krause a composer, because I know he composes his recordings, and he often presents them as a documented work. But I've watched him work, I've talked to him. He assembles and puts together pieces of music to illustrate these ideas. And, you know, some environments sound more like a symphony than others, and that's very important to Bernie Krause. And I think the basic idea to listen to the world as a whole vast music composition is something he's been really doing, and I encourage people to do that. And even John Cage encouraged us to do that, and you know, he might not, I think he probably was thinking about choruses of insects along with choruses of traffic and things like that. One of the things one area in which I do differ from Bernie Krause is I'm very interested, particularly in the Berlin Nightingale projects, in the acoustic environments connecting human sounds and natural sounds. That together they can form this kind of orchestral quality. It's not just pure nature that sounds good. For Bernie Krause, human sound ruins it. Our appearance, we're like the enemy. It's very much we are the villain. We're sinners. Nature's perfect. It's like heaven. For me, it's like, you know, if that's the way it is, then we have no hope. And we might as well just disappear. But if there's a way human sounds and natural sounds mix together, there's some hope we can be aware of this mixture and have a, you know, find a place for ourselves in the midst of this. I hope there is some place, because otherwise, you know, we're history.
I have a question about philosophy and nightingales. And you were talking about the Berlin Nightingale Project, and I want to ask you about the Königsberg Nightingale Project. Because if I think about philosophy and nightingales, there is a very famous part of the third critique that comes to mind, and that's Kant talking about the sound of a nightingale. And it's really clear that nightingales are beautiful and we love listening to them. But then he has this example. What happens if we've been spending an evening out and we've listened to the nightingales and it's so beautiful and we're in the state of aesthetic awe, and then we realize that this was just some rich guy who had perched a little boy behind the trees and the boy had made the sound. And for Kant, it all falls together. It collapses. It is no longer beautiful. How would you respond to that?
Yeah, important example. I mean, the fact is, in reality, when someone is a successful bird impersonator, it seems mostly in England this is something people do. They get a lot of applause. People love it if someone can really imitate birds really well. Like it's not seen as the same as a beautiful piece of music, but bird impersonators in England, it's been a you know, a kind of performance category people have liked. I also think that what interests me more about the Kant examples is the idea that if humans made a sound as repetitive as a nightingale, we wouldn't accept it. But for the bird, it's okay. And I think that this research being done by scientists and musicians today starts to prove otherwise, that if you listen more closely to what these animals are doing at different scales and levels, it's really, really interesting. And that as a human, together with a nightingale, it's not that you should imitate the bird, try and sound just like the bird, but together make something that no one species could make alone. And this may be a sense of like environmentalizing philosophy that Kant wasn't willing to go and think that nature is full of intelligence, nature has thought, nature has these structures. He probably didn't think that, you know, these animals are really interesting to speculate of as kind of beings who might reason and have emotions and the kind of stuff that many people are talking about today. Like it's a more familiar idea. Like, but he may give the advice, you know, that if you want to make bird music, don't just sound like a bird, do something else with the bird. And in that sense, I maybe agree with him. That you don't just want to, a lot of people think you're going out and trying to copy birds to get them to imitate you and you imitate them. I said, look, the birds don't even do that. They compose. A mockingbird's supposed to imitate other bird songs, but he composes out of the sounds of other bird songs. And until you admit that, you can't really understand what's going on. Like mimicry is not what's actually happening. It's kind of composition according to different aesthetic senses of different species. And so, thanks for bringing that up.
I have a question about the cicadas. Yeah, here. And that is because what you have shown is that there is a responsive behavior on the one hand with birds and also with whales, or at least, let's say, we think there is a form of response. And my question would be, is there also, did you manage to get a form of response or call and response, however you want to think about it, with the cicadas? And the second question would be if there is also, because you were also talking about, let's say, individual sonic behavior within birds and whales, did you also observe that with cicadas? So do they also compose their own songs?
Well, they do something more sort of stylized and set. A 17-year cicada, there's so many millions of them that they're kind of in their own world. If you chose to join into that, you're just like one of the millions. So it's very humbling.
You had examples also of individual ones.
That's what I was about to play for you. There's one slide I skipped, where with some crickets, Timothy Hill, who's an overtone singer, we went out and we were playing not with 17-year cicadas, but sort of more common katydids and crickets. And he's an overtone singer, and we in this one section, we got something similar to, it's gone. Well, the sound is off, but if it was there, you would hear it. Yeah. Yeah, so he's singing, this is sort of live, and one very high cricket starts to sing after the overtones start to expand here, Coming soon. But I wouldn't say that the most important thing is that there's a reaction of a new sound coming in. Come on. And then, well, we missed it. But in the middle, it's more that you're joining in with something where every individual is just a small part of it. You're part of the machine. So you may affect what they're doing, but you're not changing so much. Like cicadas love the sound of lawnmowers and machines. They'll all start to sing because it sort of vibrates and resonates with them. So, but, and musically, they'll respond to these noisy sounds, but what they're doing is they're not changing as much as, say, whales might change, or sometimes they don't have as many options, but they're, vibrations and movements and a sudden noise can set them off. They start doing their thing. They can also stop if they feel like, this doesn't seem quite right, maybe it's getting dangerous, and the sound stops. It's very hard to approach a singing cricket and grab him, which is also the theme of many Chinese cricket poems. You cannot grab the cricket, and you get closer, it gets silent, and you can't see him, but you hear him, things like that. And yet, it's like you're joining in. You have to humble yourself, and you play less, and you kind of make little gestures. You fit into this world of overlapping sounds. So it's like, how minimalist music can be made out of simple rules being followed. Terry Riley in C is sort of like a cricket piece. It's following these simple rules, and it works. And so, yeah, it's a different process to fit in with the world of these characters.
Well, thank you, David. That was amazing. It's very interesting because to be with a fellow person, I have done sounds performances with bees and live beehives and sonic insects for their social behavior since the early 90s. And for the longest time, I knew I was the only one doing it. And I always thought something was very interesting, and I think there was a comment earlier about the way that Japanese approach the nature sounds. And in fact, a lot of the instruments from the Gagaku ensemble, the Hichiriki, really, the double reed instrument completely sounds very, very close to the Japanese cicada. And it's become part of this whole repertoire of the traditional, the imperial music of Japan and the traditional music of Japan's orchestra, which is the oldest orchestra with the oldest written out notation. But also, even on the koto, there's ways of, but the idea is not to imitate the sound. The idea is that you actually become the bird making the sound, that you become the insect making that. So it's not the sense of the, like the German idea of what is a motif, and it's kind of a representation or a symbol of a character or a symbol of a narrative to kind of access somehow this association with this particular character within an operatic narrative of a sort. But it's actually kind of embodying on a psychic level, spiritual level, this thing, and it's a different psychological or mental space of approaching sound of nature and sound of another kind of entity. So I'm wondering, because you have such a close and interesting relationship with these sounds, if those ideas of us, Asian countries and Japan in particular, that's the one I'm more familiar with, if that's had an impact on how you think of it.
Absolutely. Thanks so much for bringing that up. And it is amazing to be in a room together with such a pioneer of insect music. Miya Masaoka was doing this many years before I ever thought of picking up a cicada and staring him in the eyes and making him sing. And that, and she did tell me she started playing with bugs because she was tired of men. They were just so difficult. Cockroaches crawling all over your body is like so much more acceptable, which I can understand. Definitely. And I was very happy to discover, somehow I found that there was an entomologist in Canada, in Montreal, Keith Kevin, who assembled in his spare time, when he wasn't doing bug science, 5 600-page books, all of poems translated from languages all over the world, merely about singing insects. So that's 5 times 600, 3,000 pages of singing insect poems, mostly from Chinese and Japanese. And some from Greek, and these short poems, deal with this sense of what's so important about, getting close into the lives and life cycles and of these insects. And you're absolutely right. It's not like a motif or copying or learning this phrase. It's really to be the insect. What is it like? Sing, fly, mate, die. Like, what is it like to be a cricket? In China, they keep crickets alive as pets as long as possible, feeding them with eyedroppers just to listen to them sing. They put wax on their wings to lower the pitch and slow down. Instead of transposing it on a computer, you take the actual bug, drop some wax on its legs, and it slows him down. And just to listen to this and still feeding him, keeping him alive, knowing he's going to die in a month or two. Like, it's a hopeless, sad pet you've got there. But it's just done because of the love of the song and to try and become the insect and share something about this life. And I've noticed in even occasionally see Chinese romantic contemporary films, instead of having birds in romantic moments, an insect will appear, a butterfly or a cricket. The insects in this part of the world, I think, are taken much more seriously as something beautiful and something to treasure.
It was so poetic. I don't know if I should ask my question now. Yeah. One question is, as far as I know, is that the whales have a much bigger or greater pitch range, how they can experience sound, than we have this famous 20 to 20,000 hertz. So I want to ask you about the choice of your instrument, because the clarinet is like our human voice, more or less. And if you are improvising, let's say with whales, you should have a tuba and a piccolo and like a group, or is it or bass clarinet or whatever?
Well, actually, the humpback whale, the range of the song of the humpback whale is very similar to that of the human voice and a cello. They don't hear sounds outside that range. But among the many whale species, there's some like fin whales and blue whales. Those largest whales, they communicate, between 30 hertz or so for the fin whale, like this pulse you can barely hear. Blue whales like 40 to 60 hertz. Dolphins and sperm whales, these high frequencies we can't hear. But the humpback whale is sort of one whose sounds are within our range. So you don't need to transpose it to hear. And so the different species are in different places. What's fascinating about the fin whale is it makes this like 35 hertz pulse. And then 2 minutes later, another one. 2 more minutes. If you speed it up and raise the pitch, you really hear woo, 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 woo. It's an exact rhythm. Can they hear that as a rhythm, that slow? Can they actually feel it? Now these sounds that are that low, sung deep enough in the water, they can travel thousands of miles in an hour. And that's the source of the title of my book about this 1,000-mile song. Like the whale songs, these kind of super low whale songs can travel that far, that fast. Humpback whale song is higher, doesn't go so far. But that's just an amazing thing. Can they actually hear that as a rhythm? You know, and so you're right, the certain species are outside our range. Dolphins, you want to transpose them down to hear them. But the humpback whale is pretty close to the range of the human voice. And that makes it an interesting evolutionary accident. We can kind of interact with them.
Thanks for a fascinating talk. It was absolutely gripping. My question has to do with a certain sort of hazard that might come along with mixing the music with the science, roughly. And I wonder whether you worry about this too. So, you know, one could do this sort of thing, of course, with inorganic nature too. One could do it with waves, with wind, with motors, car motors. One could interact in something like this way, right? You might not get anything back, but as you do in some of these cases, not all.
You can make music out of all kinds of sounds. You know, we've had 100 years or more of composers and others saying any sound can be music. But I think there's a great difference when you're interacting with.
Well, that's what my question's going to be when I pose it, which is that, you know, you've got a broad range of different types of animal audible behavior here. And isn't there a bit of a danger when one is interacting musically with all of these different diversity, that one sort of that one might be assimilating what are actually very different types of behavior to each other and to music? So, you know, there may be some of these cases where you actually would want to say in the end that there's something like animal music going on. The whale case, perhaps. The bird case, perhaps. But in other cases where animals are making noises that one might choose to interact with musically, there's something very different is going to be going on. You know, the vervet monkey, you know, it's not making music, it's telling its conspecifics in some sense that there's a snake there, or there's a bird of prey overhead or whatnot. And presumably there's going to be an enormous variety of things that are going on. And isn't there a danger in this interaction of sort of assimilating them to each other rather than doing what you need to be doing, which is differentiating?
That's why I picked these very special examples. Almost all animal sounds I'm not thinking of as being musical. I'm picking these very strange, extreme examples. The one whale species that's evolved the need to sing a long song up to 24 hours of singing. No other whale species does that. Those few bird species that sing longer, complex songs, these are the ones I'm musically interested in. The insects that sing overlapping, interesting patterns rather than, say, you know, actually, the more insects are musical than among birds. I think insect music is much more ubiquitous. But these are very specific examples I picked for that reason. You know, I wouldn't play with monkeys in a musical sense, or with dogs or wolves either, even though it sounds kind of musical, because I know what they're doing is different. And you know, many birds have calls and songs. It's the songs that are learned that have this function of defending territories and attracting mates, but they also have this kind of musical quality very often, like they have this shape and form that's closer to music. So I'm being very specific in the sounds that I pick. But that being said, I also recognize there's a real difference between kind of musical or artistic knowledge and scientific knowledge. For me to be musically happy with this process, I can have one situation playing together live with the sounds of nightingales, and the result, you know, if I think it sounds good, like, great, this is successful, I'd like people to listen to this. Either I'll play live bring people to listen, or we'll make a recording and offer it as music. But if I scientifically trying to say, these nightingales really like my clarinet playing, I would need to do it 1,000 times, do this kind of statistical analysis, and try and prove something about it, which is much, much harder. And I recognize that it's not really science. But however, when working with scientists, I said, hey, tell me what it would mean to quantify musicality. Because you're trying to do that, but you don't want to use the history of music and music theory to help you. Why not? So we have this whole process. We talk about it for several years. And then we write this paper and see if the scientists like it. It's different things that impress these people. They're impressed by a different kind of knowledge. And that kind of fascinates me that this difference is there. So you're absolutely right. These dangers and many other dangers are out there. And I try to be aware of them. But we cannot be aware of all dangers. That's why we need philosophers to poke the holes in the normal thought of mere believers in anything. Right? Which is why I actually wanted to ask you, after your talk, do you really think that the musician who cannot write down his blues solo doesn't have musical ideas? Mm-hmm. Yeah. Mm-hmm. Mm-hmm. Yeah. Right. We don't tend to just describe the structure of what they do. This kind of whale song paper is very rare, that kind of understanding. It's usually described in terms of function, in which case, say, the function of all bird songs is the same, to attract mates and defend territories. Okay, if that's your explanation, and it's the same for every bird species, why are they all so different? Could you please tell me something interesting about the difference? That approach will not get that information. You have to try and delve into the phenomenon itself, which is why I'm showing you all these sonograms, why I'm trying to musically interact. Yeah. Mm-hmm. Right. Mm-hmm. Yeah. Mm-hmm. Right. Mm-hmm. Yeah.
Hearing you cite Basho, and we've had several Japanese or examples from Japan. I remembered when I lived in Japan, I was also exposed to the sound of the cicadas in the trees. Only that I actually took them to be electric signals to put off like little mammals or angry youth,
right.
because they eventually reminded me a lot more of electric signals than of music. And I also understood them because I was put off, and most of us were actually trying not to get too close to those spaces. And so I also understood this sound patterns as a way to for animals to kind of take back spaces for themselves. So my question would be, isn't your talk of playing along or playing with, or like this concert with nature, doesn't that put too much like emphasis on the harmony between species? And isn't it sometimes more like fighting with sounds against each other?
Yeah, absolutely. That's the Bernie Krause approach. He in the Great Animal Orchestra is saying the animals are connected, all these beautiful sounds, and we are ruining it all. We're cutting down the forests, we're getting in the way, we bring in airplanes, bulldozers, buses, we're destroying this beautiful thing. And there's certainly some truth of that, but there's another kind of human activity that comes from the entire tradition of writing poems about these scary, loud cicada sounds and making them kind of resonant and beautiful. And there always have been people who have, tried to interact and fit into their environments and not see themselves as opposed to it. And in the long run, I think if we do see ourselves as opposed to nature, we are doomed. We are doomed to just be irrelevant, and there's no place for us on this planet. But if we can find a way to connect to it by celebrating it, by saving some parts of nature, by recognizing the things we value, like music and art and philosophy, that they connect to the natural world. They're not opposed. They're not what separates humans from the rest of the world. But we can find resonances and inspiration and examples out there, and we can go along with it. Like if you started playing music with cicadas, you would love the sound more. You wouldn't see it as this kind of scary thing. And some cicada sound is incredibly unpleasant, no doubt. Some of them are scary. But some human music that we love is loud and scary and strange. And that's, I believe that, I'm not sure I could prove this, but the history of human interest in noise, distortion, electric guitar, comes from bugs, from listening to bug sounds for hundreds of thousands of years. We liked noise. We want to get rid of noise, but we also love it. We love, why does mbira, a thumb piano in Africa, have little buzzy things on it to make it more resonant and noisy? We like this buzz, this kind of sound. Some say that's the voice of the ancestors cutting through. Others just think it's a cool sound, like the nightingale sound. That's like, it's you don't know if it's by accident or design, that is the sound humans also think is kind of cool that the birds are making. So you're absolutely right. Very often, obviously, nature is better off without us. But in the long run, we better figure out a way so that we can be together in this. So there's, I think, no hope. Thanks. Okay. Yeah.